First, let's talk about how each input module collects and transmits data to the Arduino. The RFID module collects data by scanning an RFID card or tag using the MFRC522 and the Arduino. When we tap the card on the reader, the unique identifier or UID is immediately displayed on the serial monitor, and we can use it directly in our program. The keypad module collects data when we press numbers on the keypad. The Arduino detects which key was pressed, and the corresponding character or number is sent and used in the program. While the IR receiver module collects data from an infrared remote control. When a button on the remote is pressed, it sends encoded infrared light signals, which the IR receiver decodes and transmits to the Arduino for processing. All three modules are input devices that send data to the Arduino. They require proper wiring and coding, and the Arduino processes the data as digital input.
Similarities and differences. However, each module works differently. The RFID module reads data from a card or tag, the keypad collects input through button presses, and the IR receiver receives signals from a remote control. The keypad requires a physical contact, while the RFID and IR modules do not. They also send different types of data, UID for RFID, characters for the keypad, and command signals for the IR receiver. Easiest and most challenging. The module that was easiest to understand is the RFID module. By simply typing the card or tag, the UID displayed immediately on the serial monitor and can be used directly. It's very straightforward and beginner-friendly. On the other hand, the keypad was more challenging because sometimes it did not consistently register the correct key pressed, which caused delays during testing. The most user-friendly input method is also the RFID module. Tapping a card immediately shows the UID, which is simple and reliable, compared to the keypad, which can be inconsistent, and the IR receiver, which requires proper remote signals. The RFID module is faster, easier, and more convenient to use.
One major technical problem we faced was arranging the wiring and finding suitable sensors or robotic components that would properly work with our intended output. Specifically, the keypad was giving inconsistent outputs and the number on the serial monitor were not always correct. We solved the wiring issue by double-checking all connections and making sure components were properly seated on the breadboard.
For the keypad, we corrected the wiring and adjusted the code, which made it function accurately and consistently. Our main debugging strategy was peer discussion. By sharing ideas and observation, we could identify the exact problem more efficiently and find solutions faster. Failure contribute greatly to our learning. Although frustrating, each mistake pushed us to think carefully, be patient, and find better solutions. This experience strengthened our problem-solving skills and helped us achieve success in the project.
The feedback components played an important role in helping users understand how the system works. The LCD helped us determine whether the code we entered and the wiring connections were correct. When the message displayed properly on the screen, it confirmed that the code and the wiring were working correctly and that the task was successfully completed. The buzzer provided audio feedback, making it easy to know if the task was performed correctly. Its sound quickly grabs attention even from a distance, which makes it one of the simplest and most effective feedback devices in the system. The LEDs provided visual feedback by lighting up to indicate whether the system was functioning properly. Working together with other components, The LEDs made it easier to monitor the system status and verify that the code was correct.
Each input module has real-life applications. RFID technology is used in security and inventory management, such as ID card, school attendance, library books, toll gate, and warehouse tracking. Keypad systems are common in security applications like pin lock doors, ATMs, lockers, and home or office alarms. IR systems are used in automation and accessibility such as TV remotes, automatic doors, motion sensors, hands-free faucet, and obstacle detection. For security and inventory management, RFID is best because it is fast, contactless, and accurate. For basic security, a keypad is a simple, cost-effective, and user-friendly. For automation and accessibility, IR systems are ideal because they allow touch-free automatic operation.
This is our meta-reflection for our whole robotics journey. The most memorable failure moment we encountered was when everything else was working except for the servo motor. A perfect occurrence that involved the RFID and reading and scanning the card correctly, and cooperating with the LCD in showing the correct message, and finally the LED turning on, indicating that our system was functioning well. The moment when failure occurred, the keypad was not responding at one point. Initially, nothing was displayed on the LCD screen. We realized later that the wiring was loose and pin code was misplaced. We solved it by checking the wiring. So in this whole journey, we have lesson learned that we can advise to our fellow or future students. The lesson is to enjoy every moment of your lab experiments. Only meeting once a week will give us limited time, but the memories you will gain from every success and every failed moment for every component you will try. Don't rush. Check your wires and code step by step. It is normal to make mistakes, and that's a learning curve in itself. Simplicity in design is key. There is no need to overcomplicate a sensor. Just keep it simple.
Hindi gumagana yung servo.